Alright, this should be part 1 of 3. There's 3 pages of notes. We'll do a video for each page. This is the first page, which is actually a very quick review of exponentials and logs. Some of this you should have seen in pre-calculus and or algebra 2, so it's going to be kind of a review. The most common base for logarithms in calculus is e, which is just a number. This is a decimal approximation of that number. This is how e has actually been calculated. You notice that it is a limit. The limit as x approaches infinity of 1 plus 1 over n to the nth. We are going to have 2 problems on your homework that have you use e in its typical form, which is compound interest, and it's when you compound continuously. So basically as the number of compounds approaches infinity, you use this formula, which you may have heard or called PERT, for P-E-R-T. A is your ending account balance. P is your principal or your start balance. Sorry about the bad handwriting. And E is the number, constant. It's also on your calculator. So if you look at your calculator, it is right there above ln. I know that's kind of not focused. Not sure why that is, but anyway, right by the ln there's an e to the x button right there. That's e to the x. So that's just the number 2.71828, and then up the exponent is r and t. R is the rate, which must be as a decimal, and t is time. So if we have a question that says a bank you know offers a 3-year CD that earns 3.64% interest compounded continuously, if 10,000 is invested, how much will be worth in 3 years? So we start looking at what all these represent. There's my time, there's my rate, but I'm going to use that as a decimal, so I'm going to change that to 0.0364. And if I invest 10,000, that's my principal. That's the amount I originally put in. So I want to know how much I'm going to have in that account after 3 years. So I use the formula. I'll write the formula down here. A equals PERT. I don't know A, but I know I started with 10,000. E to the rate of 0.0364 times time, which is 3 years. So in this case, I can just literally plug that right into my calculator, exactly like that, to get my answer. So I will turn this thing on, put it right next to that so you can kind of see it. I'm going to type in 10,000. E is where I showed you it was, so you have to hit that little second natural log button, and then up there I'm going to put 0.0364 times 3. All of that goes up as the exponent, hit enter, and that's the amount of money I would expect to have after 3 years. So whatever that was, I can write down here. Looked like it was $11,153.85. So the next one, how long will it take for the account to be worth 11,000? So this is how much I am going to end with. That is my account balance at the end. And I'm asking how long will it take. So how long will it take is t is the question. So I now can use again the PERT formula, but now I have an 11,000 on this side. I still am starting with the 10,000, and I'm just wondering at 3.64%, how long will it take? So the problem here is I've got my variable as an exponent. So the first thing I would do was divide away both sides of the 10,000. And then, so if I do 11,000 divided by 10,000, if you do that on your calculator, you would get 1.1. So over here, I'm going to rewrite it as 1.1 equals e to the 0.0364t. Now, one of the properties of logarithms is to get rid of a variable as an exponent. If I take the natural log of both sides, so I'm taking the natural log of this whole thing, then the left side will be, again I've done the same thing to both sides, the natural log of 1.1 equals, and when I take the natural log of e to the 0.0364t, one of the rules, and I'll look at it again in detail for you, is that the exponent drops in front. So 0.0364t drops in front of the ln of e. It was an exponent. When I take the log of it, one of the properties is exponent drops in front and becomes a multiplier. And we'll look again in a minute. The natural log of e just equals 1, so that doesn't exist. And now, to find the time, I just divide both sides by 0.0364. And so I have to punch in natural log of 1.1 in my calculator. So if I come over here and hit the natural log button, which is right there, right below log, natural log of 1.1, close the parentheses, divided by 0.0364, enter, 2.62 years. So time would be about 2.62 years. All right. Third type of example is a note will pay $50,000 at maturity in 5 years from now. How much should you be willing to pay for the note now if money is worth 6.4% compounded continuously? So again, I've got, that's my rate, but I need it as a decimal. 5 years is my time, right there. So t equals 5. And I'm getting paid $50,000, which means that's how much I'm going to end up with at the end. So that's my A, that's the end. And I want to know how much is it worth, how much should I be willing to invest basically. So if I go back to my PERT equation, P equals E to the R, we'll start over. A equals PERT. I know how much I'm going to end with, $50,000. I do not know how much I have to put in originally, but I know I'm going to have a rate of 0.64 and a time of 5 years. So the problem we did, number 2, is actually the most complicated one because we have to do the log of both sides. This one, again, this business right here, I can just punch in my calculator, and then whatever that is, I divide away to get p by itself. So at the end, I'm going to have this principal is going to be 50,000 divided by whatever this number is. So principal is going to be 50,000 divided by whatever I get as a decimal from this. So if I do that in my calculator, again I pull up that e function and I need it to be 0.064 times 5. That gives me 1.377, 127764. I've kind of abbreviated it here, but in my calculator I'm going to do 50,000 divided by a second answer because it'll pull up that whole decimal. And I should get an answer of 36,307.45. So I should be willing to invest $36,307, and in 5 years I get payback of 50 grand. Alright, so these are the log laws you should be familiar with from the past. If you're multiplying inside of a logarithm, you can separate it as 2 separate logs added together. Notice the base is e on all of these. We don't write the base e, but ln means the base is e. If I'm dividing inside of a logarithm, I can separate the 2 logs by subtraction. And this is the one I used a minute ago. If there's an exponent inside of a log, it can drop in front and become a multiplier. So ln of a to the p is the same as p times ln of a. So we're going to use those here a few times. A couple other things you might want to just have down is that the natural log of 1 equals 0. And the natural log of e equals 1. And again, these up here work both directions. If I have 2 separate logs separated by addition, have the same base, I can write it as a single log with multiplication. If I have 2 logs separated by subtraction, I can write it as a single with division, and I can always pop the exponent up if I need to. So we'll look at these as we go through certain characteristics of logs over the course of this particular lesson. There goes, end of part 1.